So now we're going to assess how visible thinking can be used in a mathematics classroom. In this demonstration, we're going to complete a mathematics investigation based on the topic of patterns. The hypothetical situation is that this is a practice investigation done as a class. Now ideally, we would have gotten you into small groups and scaffolded this activity through verbal and social processes, but due to the change of platform, you're going to have to follow a question-by-question tutorial on the investigation. In this demonstration, you'll be able to see how each question links to a mathematical argumentation step, as well as a particular visible thinking routine. Feel free to pause before the solutions are given out. So a mathematics class is organizing a charity dinner. The organizers need to work out how many people they can fit into the hall they have hired. The tables can be arranged with 6 people sitting at each table. The first question that was given was, using diagrams, figure out how many people can sit around 3 tables. Here, students had to perform the generating cases step of argumentation. Along with question 2, they will create a visual argument of the amount of people that can sit around a table. Once the student has been allowed thinking time, the teacher would then use the first thinking routine, the explanation game. This thinking routine will get students to observe the details given in the question and to verbally explain parts to build their argument. In this case, students would use the diagrams to observe this detail and explain their argument. Moving on to question 2, using diagrams, figure out how many people can sit around 4 tables. So again, students will be given the chance to consolidate the arguments through a question with a similar argument. A student can then use the second question to either confirm their first argument or change the argument verbally. For example, they might notice that their diagram was incorrect for question 1 and then prepare a new argument from question 2. So the teacher will then be able to see this instant feedback that the students are doing or giving to themselves. Question 3. Complete the table below to help work out how many people can sit around each number of tables. This is the conjecturing step of the argumentation, where students are expected to make claims. Here, students are to make a claim in regards to the observation from question 1 and 2. So using the thinking routine of the microlab, students will then focus their attention and analyze the patterns found verbally in the last 2 questions to help them fill up this table. So in question 4, students are expected to describe the pattern of the number of people that can sit around tables. So students are then to proceed to the justifying phase of argumentation. Here, they build on the reasoning by describing the patterns that they observed. So the thinking routine present in this is the what makes you say that routine. This thinking routine pushes students to give evidence for their argument, which in this case, students are asked to describe their finding. And then they are to write an algebraic rule to describe how many people can sit around different numbers of tables. So students then move into this last phase of argumentation, concluding. Here, students will close in on the truth and summarize their findings. In this case, the students will have to come up with an algebraic rule from their findings in the previous step. The student is using the claim support question routine to identify generalizations in the pattern they found, and then in the next question, they apply this generalization to support the argument by applying the rule that they came up with to find solutions. So in this case, using the rule that they come up with before from studying patterns to calculate for larger amounts of tables and people. So we can then extend this investigation activity by asking further questions that gets them to consider other scenarios. So the students will still be using the claim support question routine, but in this instant they are considering counter-arguments such as, would the seating be different if the tables are pushed end to end or side to side? They will then be asked to reconsider their argument and see which arrangement will maximize seating. So this is a good routine to extend their thinking by applying what they already know and apply their knowledge into different scenarios. Now to wrap up, we will examine the limitation of the visible thinking framework. Firstly, not all of the 21 thinking strategies that was proposed would fit all learning areas. For example, the thinking routine of color, symbol, image would work great for an English classroom, but would rather be useless for a mathematics classroom. Visible thinking also only allows for reflection to be internal to the routines, and does not explicitly designate time for students to reflect on their learning. In fact, a very big downfall to visible thinking is that everyone thinks differently, and a student's way of thinking might not be as straightforward as others. So teachers might mistake this as student not understanding the content. The verbal and social process of visible thinking may also disadvantage shy or socially lacking students who do not want to openly contribute, or students whose English is their second language, who does not know how to express their thoughts eloquently. Students with hearing and speech impairments might also be highly affected, as they might not be able to contribute and learn verbally. So the thinking process is also time-consuming, in the sense that it needs to be done with extensive practice and repetition for it to be effective. So these routines need to be habitual to their learning. And additionally, much like the other strategies, visible thinking will fail in an uncooperative environment where students are not willing to verbally contribute or have the want or skills to discuss their thoughts verbally. And lastly, the thinking routine parallels the idea of learning by inquiry, which has been proven to be detrimental for low ability students in maths who work best through explicit modes of teaching. In conclusion to all of us experts, in part 1, we showed how the 21 thinking routines that comprise visible thinking constitute a flexible toolkit to enhance students' thinking skills across a range of learning areas. In part 2, we showed how visible thinking is the product of around 30 years of research centered in cognitive psychology. In part 3, showed how all the subject areas can encourage a culture of thinking and deeper understanding. Visible thinking routines do this in a way that makes thought processes observable to both teachers and students. In part 4, we examine how visible thinking has relevance to mathematics, where an open, investigative process is more appropriate for developing deeper learning than a closed problem-solving approach. In part 5, we showed that visible thinking and mathematical argumentation has direct links, and that through the use of these routines, teachers can track, scaffold, and extend student learning. In our final part, we considered the main limitation of visible thinking in promoting student learning and how visible thinking had the potential to be detrimental due to its social and verbal processes. We're just going to very quickly clarify the handout as well. It's mostly straightforward, starting with a little bit of history about visible thinking and Harvard's Project Zero, and how its 3 core practices are revolved around the reflective professional practice, documentation of student thinking, as well as thinking routines. And in our presentation, we decided to focus on the thinking routines. There's also a brief outline on how the thinking routines are split into 3 categories, so introducing new ideas, synthesizing and organizing new ideas, and digging deeper into ideas. When compared with mathematical argumentation, we found the common objectives between both of these processes, which include fostering a deeper reasoning and understanding of content and so on. After discussing all that, we then summarized how visible thinking has its links to the curriculum. So on the second page, we've listed the 21 thinking routines that we've referred to and how each of these categories or phases has 7 thinking routines. We've categorized the thinking routines here for you guys and also linked an accessible document briefly explaining each of these routines. We also listed the limitations to the visible thinking routines and how these can be consequential to your teaching if you do choose to use it in your class.